In the last video, we learned about directional control valves, controlling the direction in which the air travels. Now we're going to look at further control elements in pneumatics. Let's look at the shuttle valve. The shuttle valve has the OR function. When the valve receives a signal from either input, there is an output. The red tubing is providing the input for the shuttle valve. The output of the shuttle valve is connected to the 5-2 directional control valve, pilot-operated spring return. And the working port of that directional control valve is connected to the double-acting cylinder C. Let's look at another valve, the AND valve, where two inputs must be present before there is an output. The input signals are provided by the red tubing and are connected to the push button 3-2 spring return directional control valve. The output of the AND valve is connected to a 5-2 directional control valve, pilot operated spring return. Its working ports are connected to a double acting cylinder. Let's introduce another control element, the flow control valve with check bypass. The flow control valve is connected to the cap end of the double acting cylinder in a meter-in arrangement. So what do we mean by metering in arrangement? Well, what we mean is that we will be controlling the amount of air, reducing the amount of air getting into the cap end of the cylinder, causing the rod to extend more slowly, dependent on the position of our needle valve on the flow control valve. You can see the rate of stroke changes as the needle position changes on the flow control valve. Alright, here we have a pneumatic setup whereby either push button, either the black or the red momentary push button, controls this piloted spring return directional control valve, right? Either button, when pressed, causes the cylinder to extend. This is a double acting cylinder, all right? When the cylinder is retracted, we have this green puppet indicating that the cylinder is retracted. When the cylinder is extended, this red puppet light will, much like that. The red puppet indicator indicates when the cylinder is extended. The green indicates when it's retracted. We're able to control the speed of the extension with this check valve, with this flow control valve. Okay, that's a flow control needle valve. Pay close attention to the markings on the back. It shows you the orientation of the check valve. So, as I said, when either push button is pressed, the cylinder extends. We could control the speed of the cylinder by adjusting this needle valve. Okay? This shuttle valve here is being employed so that when either input is sensed, we get an output. That's the inputs being the push button. All right, so overall here we're using 2 directional control valves, 5-2 pilot spring return directional control valve to control a double acting cylinder. So we're looking at this pneumatic circuit here, whereby all the yellow lines represent the feed lines from the manifold to the pressure supply port of the different valves that we're using. We're using 4 different directional control valves, 3-2 directional control valves, 1 5-2 directional control valve. Each of them are actuated differently. These 3-2 directional control valves is a toggle, a momentary push, and this 5-2 is a double piloted actuated valve. So in this circuit, either push button is going to cause the cylinder to retract when extended, provided it is not getting a signal to extend. Okay, so if we follow the tube lines, the tubing, this pilot signal on this 5-2 directional control valve is getting a signal. It is into this OR fitting, this shuttle valve fitting. This shuttle valve works by either input provides an output. So the inputs in this case are the 2 push buttons. So if either push button is depressed, we get an output from this valve to signal our pilot signal in our 5-2 directional control valve. When this gets that 5-2, when this 5-2 gets that signal, the spool internally in this valve is forced over, forcing the air to pass from the pressure manifold out this port here. This port is B2. If you look on the valve, there's labeling. It forces the air to flow from the pressure port out to B2, causing the cylinder to retract. Okay? If either push button is depressed, forces the spool over, forcing the cylinder to retract. And this pilot signal here, the directional control valve, this 5-2 directional control valve, its pilot signal is from this toggle switch. When the switch is toggled, it forces air to the pilot signal. The pilot signal forces the spool over, forcing it to shift, causing air to flow from the pressure supply port out A4. As it travels out of A4, it flows through this flow control valve to the extension port and causes the cylinder to extend at a rate that is based on this flow control valve that can be adjusted. So let's turn it on and see it in work. So I signal, which now air is coming from the pressure, from the manifold. It's now traveling to this pilot signal, forcing the spool over forcing air into the cylinder casing, forcing the cylinder to extend. If I remove that signal, there is no air coming out of this anymore. There is no air, but the spool stays shifted over and the cylinder stays extended until the pilot gets a signal from the opposite end. When it gets a signal from the B port, then it's going to force air to force the cylinder to retract. Okay? So if I depress either push button, we're going to get air going to this pilot signal, forcing the spool over, forcing air into the front of the cavity of the cylinder, forcing the rod to retract. Okay? As we see here, even after the signal is removed from this directional control valve, the spool stays shifted in its last position. So when there is not a mechanical spring employed, these valves have memory. They stay in the last shifted position until they receive a new signal. Okay?